Hey, what's going on, guys? It's me, Ezra, and I'm here to make a video. I got this wheel right here. I'm gonna spin it to see what I gotta do for this math project. Let's spin. Ah! And there we go, guys. Seems like the answer is I gotta do number 8, which is like this super cool, interesting, I don't even know, so let's just jump into it, guys, alright? So, here, check this out. Check out these succulent numbers right here. This is our problem. We need to figure out the transformations from a y equals x that create this interesting equation. What transformations need to be done? Well, there are 7 on my list. Number 1, f of x equals the square root of x, because that's our base right here. We gotta get this square root sign in. All right, so now that we got that done, up next we need to shift it to the right 3. And how do we do that? Well, we put the number into the radical symbol, which would make it x minus 3. Now, it's minus 3 because we're moving it to the right 3, and when you're changing the value of the x coordinate, you do the opposite, right? So to move it to the right 3, you subtract 3, even though normally negative 3 would be 3 to the left of the origin. You got it. So that shifts to the right 3. Up next, we gotta reflect over the y-axis. So to do that, we do the opposite, because it's the opposite of the x coordinate. So negative x minus 3. And we put the x minus 3 in parentheses because we're reversing all of that afterwards. And why are we doing why are we doing the shifting to the right before we're flipping over the y-axis? Because up here, whoops, out of focus, you could see that the negative is going to be distributed to both the 2x and the plus 6. And originally, it's x minus 3. So, how do we get it to become 2x plus 6 if it's originally x minus 3? Well, we already have the negative part. That's going to be distributed to both the x and the negative 3, which would make it negative x plus 3, right? But how do we get it to be negative 2x plus 6? And the answer is step 4. F of x equals square root of negative 2 times x minus 3. And when you distribute all of that, you get negative 2x plus 6. But what does this entail? What does it imply? Well, it implies that there's a horizontal compression of 2. Now remember the fact that when you change the x coordinates, things are reversed, right? So, although normally when you multiply coordinate by 2, it would expand the number by 2. When you put the 2 inside the radical, when it's affecting the x coordinates, it actually compresses the values. And that's all there is to it. So that's a horizontal compression of 2. Next step, step 5, we have to reflect over the x-axis. Now, why do we need to do that? Well, if you look back up here, there's a negative symbol over here. And all you gotta do for this one is add a negative in front of the negative 2x minus 3. Let's do a little dance for it, huh? Do a little dance. And we're back. So, 6, we gotta do a vertical compression of 2. Now, remember, when you're changing the y value, which is vertical, that's what it implies, y means up, you gotta do it normally. You're not doing it reversed anymore. So, if we're doing a horizontal compression of 2, then you do a 2. But if we're doing a vertical compression of 2, then you do 1/2. Bam. Look at that. So, 1/2 square root negative 2x minus 3, and that's it. And then, our final step, we're shifting everything up by 3. Now, since we know that when you're changing the y coordinate, everything's normal, we do that, 2 times negative 2 times x minus 3. And now we, outside of the radical, we do plus 3. And when you distribute everything, you get negative 1/2 square root negative 2x plus 6 plus 3. There's our answer. Now, the one thing to really remember with this is that when you're changing the x coordinate, you do everything in reverse, right? When you're changing the y coordinate, you do everything normally. And when you're reflecting over the y-axis, even though it sounds like it's a transformation of the y values, it's not, because if you take a look at this Lie graph, this is the y-axis, right? This is the x-axis. And when you reverse a function like this, or no, let me do it better. Let me do something better here. Let's say this is your function. When you reverse it over the x-axis, you're doing it like this, which changes all the y values, but not the x values. But when you flip it over the y-axis, it'll look like this, which means you're changing all the x values, not the y values necessarily. Like, see, like this is over here now. So you're negating the x value. You're not negating the y value. But over here, you're negating the y value. So that's why a reflection over the y-axis affects the x value and not the y values. So that's part A of my problem to change this. Now, the next one is part B. So let's do a little bit of part B, huh? Huh? Do a little dance for it. Next part. Part B. Now, here's our goal. We have these numbers. These are our original coordinates. And it doesn't matter, but where's it fall on the graph? It falls about here. Check that out. Let's zoom in on it. And let's turn it into a smiley face. Boop. Boop. Look how happy it is to be doing math. Let's hear it say, I'm happy to be doing math. I'm happy to be doing math. Wow, you're so happy to be doing math. Anyway, back to the problem. We got b, -6, and 5. Now, for part A of b, we have to turn that, we have to put that through this function. So y. And what do we get when we put it through this function? Well, let's see. Let's see what we do. So first of all, we have this. Now, what that does is, this is affecting the x value. This entire part is affecting the x value. This is in reverse. Remember that part? So we subtract 3 from the x value, which means we shift it 3 to the left. And when we shift it 3 to the left, that becomes -9. Now, let's do the next part. So then, you multiply y by 4, because order of operations says multiplication comes before addition. So, look how happy it is. Let's multiply y by 4. So 5 by 4 is 20, plus 2, that's a plus, is 22. So that's the answer to part A. It's -9, 22. Now, let's do the next part. The next function we need to plug in -6 and 5 to is this baby boy. It's a y again. So first of all, we compress -6 by a factor of 4, which becomes -3/2. And for this one, we just keep it the same because y is already positive. So that's it. -3/2 and 5. Oops, sorry, that's an absolute value. But since it's not within the parentheses, it only affects the y values. So take a look at that. So that's why we can have -3/2. And for the last part, not the last part. Here's the last part. Negative g x over 2 plus minus 1. Now, here's a little thing that you might have missed. You always need to make sure x is by itself when you're doing this, when you're doing a problem like this, because you're gonna get the wrong answer. Originally, I just did it like this. Now, but let's see what happens if I just do it wrong. You get a bad number, and because if you say you move x first to the right and then you multiply x by 2, then you'd be wrong. So first, you gotta multiply this by 2. X minus 2. And then, since you have negative y, you negate y. And you'd get negative 5. That's it. Now just to review this again, this part. See, the reason you can't is because of order of operations. If you had x over 2 minus 1, right? You'd and I originally did x, add 1 to the x, right? And then multiply the whole thing by 2, which would be negative 6 plus 1, which is negative 5, times 2, which is negative 10. But that's very wrong. See, as you can see here, it's negative 8, not negative 10. So what you have to do is, you have to make sure x is by itself, which means you multiply all of this entire phrase by 2. And then you get your answer, which is negative 8, negative 5. And we're done, baby. Smiley face. Happy New Year. Do a little dance for it.